Welcome students, we are back with another lesson. In this lesson, we will derive our third kinematic equation using our graphical method. So far we have derived the first kinematic equation, the velocity time relation. Then we have derived your second kinematic equation, the displacement time relation. And today we'll derive our third kinematic equation, which is your velocity displacement relation using your graphical method. Fine. Now in this graph, OA represents your initial velocity, OC represents the final velocity, OE represents the time interval. Since AD is also equal to this length, so AD also represents the time interval. Here this BD represents the change in the x-axis, or I can say the change between the final velocity and the change between the initial velocity. This one is the change in the velocity. Similarly, this represents the change in the time interval as well. Here the initial time is 0 and the final time is t. So this time interval also represents the change in the time along the x-axis. Next, the slope. This slope represents the change in the velocity per unit time. Fine. Or I can say this slope also represents your acceleration. So acceleration A can be written as the change along the y-axis, the change along the velocity dB, divided by the change along the x-axis, the change along the time axis AD. Clear? So I can write the slope as the ratio of dV upon AD, the change along the y-axis, the change along the x-axis. So this dV represents the change along the x-axis. That means the difference between EB minus ED, this point. Okay. From this total length, if I subtract this length, I remove this part of the length, then I will get dB. Fine. So dB can also be written as EB minus ED. Fine. Similarly, this AD can be written as OE, since this one and this one are of the same length. Now if I cross multiply, I can send this OE here and A to the denominator. Then I can write down OE as EB minus ED upon A, which is your acceleration. Fine. So let's give this equation a number. Fine. So in my last class, I've showed that the distance traveled in the velocity time graph can be calculated by calculating the area of this trapezium. Fine. So can you see this yellow trapezium? The trapezium OABE. This represents the distance traveled by the object in time t with the change of the velocity from u to v. So area of trapezium OABE is the sum of the parallel sides. Your parallel sides are your EB and OA. These two sides are parallel, multiplied with the height of the trapezium. In this case, the height of the trapezium is this one, which is also can be written as OE. So the trapezium area can be written as half of the sum of the parallel sides into the height. Now here we have already found out the value of OE. OE can be written as EB minus ED. EB minus ED divided by your acceleration. So let us substitute this value here. Right? So this is from your equation 1. So let me write this equation in my next slide. So using this algebraic expression, that is AB multiplied with A plus B, A minus B multiplied with A plus B, or I can also write a plus b multiplied with a minus b will give us a square minus b square. The same relation can be applied here. Here this one will represent a, ed will represent b. So eb plus ed multiplied with eb minus ed can be written as eb square and ed square using this relation. Fine. Now what is your eb? eb represents the final velocity. This part represents the final velocity. So instead of eb, I can write small v. Similarly, your ed, this part, okay, this part represents your initial velocity u. So I can write ed square as u square. Fine. Now I can take this 2a and I can cross multiply it here. So I can write 2as equals to v square minus u square. Or on further simplification, let me write this on the left hand side and this one on the right hand side. So I'll get my third kinematic equation. V square minus u square equals to twice of as. So this is your velocity displacement relation. Fine. So I have derived your three kinematic equation using the graphical method. Fine. So that's it for today's class. Thank you. And if you have any confusion, please feel free to ask. I will re-explain it to you again. And in my next lesson, I will start a new chapter, chapter 4, motion in a plane. Fine. So again, thank you.